So in this video, we are going to talk about functions. And we're going to start off with a definition, and we're going to have a couple of quick examples. And then we're going to look at graphs and see how it ties into stuff that we're going to be working on in class. So definition, or definitions. A function is a relation that assigns to each input a unique output. The set of all inputs, or x values, is called a domain. The set of all outputs, or y values, is called the range. And so this seems like a relatively abstract definition, but let's look at some concrete examples to get started. So let's look at these points. Each one of these points relates an x value to a y value. And we have 1, 2, 3, 4, 5 points. So let's organize the x values. The first one would be -2. Second one would be -1, then 0, 1, and 2. My y values, -8, -1, 0, 1, and 8. If we look at what happens, this -2 was assigned to -8. They're going straight across. There's something else going on there that we'll talk about later on in the semester. But I'm not going to bother with the arrows, just do lines. Okay, so they're going straight across. So 1's assigned to 1, 2's assigned to 8, and so forth. So I'm looking at this -2, and in order to figure out if it's a function or not, I want to see how many outputs it has. Well, -2 goes to -8. It doesn't go anywhere else. That's unique. So -8 is unique to -2. And -1 gets mapped to -1 or sent to -1. Those are words that we can use. 0 goes to 0, 1 goes to 1. So I don't have any of these going to multiple different places, so this is a function. If I look at example number 2, did I write that's a function? Yeah, I did. Okay. If I look at example 2, I'm going to do the same thing. X, F4, 1, and 0. And I have a 1 and a 4 here. I'm not going to write it twice. I'm going to only write it once. I'm going to look at my y's. I have -2, -1, 0, 1, and 2. So my y values and my x values are separated into columns. If I look at 4, 4 gets assigned a -2, but if I look at the end there, 4 gets assigned a 2 as well. Hey, wait a minute. Something's going on there. 1 gets assigned to 1 and -1, and 0 goes straight across to 0. And 4 goes to -2 and 2. So there's two different outputs. The outputs are no longer unique here. Same thing with -1 and 1. 1 goes to two different places. So because this input does not have a unique output, this can't be a function. So it's not a function. Functions have an importance in everyday life. In fact, everyone in this class has a student number. If you go to student services and you need to find something out about your bills or your grades or anything like that, the student services folks are going to ask for your student number, not your name, because there might be more than one person with your name. But only you have your student number. So that's the input that has a unique output of you. So there's some quick examples. If I want to look at what's going on graphically, let's plot these points. So we get a picture of what's going on with this. X and Y. 0, 0, 1, 1, 2 goes to 8, 4, 5, 7, 8. And I apologize for counting. -2 goes down to -8. And so what's going on here is whenever I have a set of points, I can always try to graph them and connect the dots. And in this case, I have x values going to y values. It turns out that this is the equation y equals x cubed. And we're going to talk about in a moment new notation for equations that gives us function notation. This is a function. In this case, y depends on x. Y is by itself. We talked about that in a previous video. And if I look, if I draw a vertical line, let's pick this color. If I draw a vertical line, this vertical line is only going to meet an x value once, or it's going to cross a point on this graph once. And this is going to give us a vertical line test that we're going to talk about. But each input, so my x value goes up and down, it only hits once. Whereas if I look at this other one, it's going to look like that. And we're going to get this sideways parabola. And so graphically, if something's a function, I can draw a vertical line anywhere on the graph, and it's going to only intersect that graph once. Whereas if something's not a function, there's going to be at least one point where I draw a vertical line and it's going to hit the graph 2 or more times. And we'll talk about that in a little bit more detail, but I want to give you guys a picture of what's going on here. So we talked about graphing equations y equals 2x plus 1, and we used the terminology of y depends on x here because that allowed us to pick x values, plug them in, and get y values, right? Well, we can have this new grown up notation. So instead of y depends on x, let's look at y equals f of x. And this is y is a function of x. So this is new notation here. The function notation, this f of x, f is the function, and x is the input, and y is the output. So let's compare these two notations. If I wanted to graph y equals 2x plus 1, I can make my t-chart, and I can pick values for x and plug them in. I can plug in, say, -3, 0. I can plug in 1. And it doesn't matter what I plug in. I'm going to plug that number into this and evaluate it. So if I plug in -3 for this, 2 times -3 is -6. -6 plus 1 is -5. If I plug in 0, I get 0 plus 1 is 1. If I plug in 1, I get 2 times 1 is 1. I'm sorry, 2 times 1 is 2. 2 plus 1 is 3. And I get those points, and I can graph it if I want. I'm not too worried about graphing that just yet. I want to look at this new notation here. So if I were to say f of x is 2x plus 1, I can do the same thing. We would actually get the same t-chart. What I'm going to do is I'm going to show you how to plug things in. So f of -3 means 2 times -3 plus 1. So wherever I see the x in the original function, if I have a -3 as an input, again, that's an input, right? That's going to be my input over here too. And that's going to give me -6 plus 1 is -5. So this is my y value from over here. Same thing if plugging in 0. And if you are noticing, those inputs are going to those outputs. So that's how you use that notation. You're not always going to get these linear equations or linear functions, as we're going to learn. If I have f of x is x squared plus 2, we're going to learn that this is a quadratic. It's going to give us a parabola shape. We're not going to graph this just yet. Actually, why don't we graph it? We will graph this one. Change my mind. If I want to look at x equals 2 and evaluate it, I'm going to plug in 2 for x wherever I see x in the original function. I'm going to get 8. If I plug in x is 1, I'm going to get 1 squared plus 2 times 1. Let me write that later. That's going to give me 3. And let's start keeping track. Let's see, x. I'm going to write y because y is f of x. 2 gives me 8. 1 gives me 3. Let's plug in 0. If I plug in 0, I get 0. And if you need to compute these on your own, feel free to pause it and check the work. And I'm running out of room here. I'm going to try to fit everything. Let's do x is -1. F of -1 is -1 squared plus 2 times -1. That's going to be -1 squared is a positive 1 minus 2. So 1 minus 2, that's -1. And finally, x equals, I didn't write that -1 there correctly. I apologize. That's x equals -1 and then -2 if we didn't see that coming. F of -2 is -2 squared plus 2 times -2. That's going to be a positive 4 minus 4, and I'm going to get 0. So -2 goes to 0. So this is a function as well because each one of these inputs goes exactly to one output. We do have an occurrence here where 0 goes to 0, -2 goes to 0. Why don't we start graphing this just to make sure? I'm going to slide over this way. So let's see, -2, 0. And for some reason, that -1 keeps eluding me. That's 6 and 8. So if I were to draw this picture, hey, this looks just like a parabola. If you remember that from a previous math class. I'm sorry, it's a little shaky. This is what this graph is doing. And you can figure pretty quickly that if you draw a vertical line anywhere, it's only going to hit once. And so this is indeed a function, even though you might have been wondering about this. And really, is there an x value that's going to 2 different places? If 0 is going to 0 and going to -1, that would be a problem. Having 2 outputs that match isn't a problem. Real quick, I want to talk about the vertical line test. And when we're wow, that's bad. Let's do that again. A little better. If we just look at some pictures, if I were to have a graph of a straight line, this passes a vertical line test with flying colors, and straight lines almost always do. We can look at horizontal lines. Those are also straight. So I have a horizontal line. The horizontal lines passes a vertical line test with flying colors, right? The only line that doesn't pass the vertical line test would be vertical lines. If I were drawing a vertical line, that would be x equals 3, for example. That does not pass the vertical line test. Because if I draw a vertical line, that's not hitting anywhere. But then if I draw that vertical line, x equals 3, every point hits. Some other shapes, you can graph circles, and actually you can come up with equations of circles. And that's a crappy circle, but I think you get the point. Circles won't pass the vertical line test. So if you're doing homework and you're being asked about the vertical line test, usually it's going to have the picture and it's going to ask you, does this pass the vertical line test? Yes or no. And think if it only touches once anywhere, then it passes. If it crosses more than once anywhere, then it fails. Some other goofy curves, you might see things that look like this. And yeah, that fails the vertical line test. And in the next lesson, we're going to talk a little bit more about graphing functions.